As far as distributions go, the uniform distribution is about as straightforward as they come. It has constant probabilities across the entire range of values in its domain. Let's have a look in code. Okay, in our probability notebook, we've now made our way to this segment on distributions in machine learning, and we're specifically in this section on the uniform distribution. So if you've been following along with these live lessons, it might have been a while since you last ran some code in your Colab notebook if you're using Colab, and so you might need to run all of the cells above here. So if you do need to do that, you can go to runtime and run all the cells before after clicking on one of these cells around here. All right, so the uniform distribution, we already talked about that. They're as straightforward as they come. So let's create one here. We'll use the NumPy uniform method from the random module. And the only argument that we're passing in is how many data points we would like to sample from this uniform distribution. We're going to put all of these 10,000 values into a vector called u. I'm going to change the Seaborn plot style to ticks because I thought it looked better for these plots that we're plotting now. And then we're going to use the Seaborn distribution plot, and you just pass in u here. And let's see how it looks. There it is. So that's a uniform distribution. So by default, this NumPy random uniform method samples values over the range of 0 to 1. So you can change that. That's a parameter. But the point here is that whatever the range of values that are allowed in your uniform distribution, the probability of sampling a point is uniform. So the probability of sampling a point here or here or here, it's equal. It's a uniform distribution. All of these buckets are roughly the same size. You could increase the number of values that you sample, and as you increase that to 100,000, to 1,000,000, and so on, these buckets will look more and more and more even because of the law of large numbers. Real-world examples of a uniform distribution include dice rolling and card drawing. These are examples that we've talked about a lot already in these live lessons. Although one thing to note here is we are largely talking about probability density functions here with continuous random variables, whereas dice rolling and card drawing are discrete random variables, so they're probability mass functions. Other examples that are really PDFs are model hyperparameters. So if you are already familiar with machine learning models, you might be familiar with selecting hyperparameters for your model. And if there's a particular range that you think the hyperparameter should range over, say, the number of neurons in a artificial neural network in a particular layer, or the number of layers in the artificial neural network, you might sample from a uniform distribution to figure out the optimal value of a hyperparameter when you're searching over that space. So yeah, uniform distributions, a common choice. Other things outside of machine learning that have a uniform distribution, the emission of radioactive particles, economic demand, they use a uniform distribution in those models, as well as a very specific engineering example here of analog to digital signal quantization errors. Those also happen in a uniformly distributed way. Nice, so that's the relatively simple uniform distribution. Up next is the Gaussian distribution, a workhorse of probability theory.